In this video for the accelerated geometry Mach 3 review, I am going over numbers 1 through 11. So in another video, I'm going over numbers 12 through 23. So here, this is just starting with our quadrilaterals. So I'm going to go ahead and also label to prove that this is a rectangle. And so in this video, guys, I'm going to focus on for 1A and 1B, the side lengths. So not just the lengths, but also even the slope, because if you have the negative reciprocal, right, then you have 90-degree angles. So we're going to prove that this is a rectangle. So let's start with side AB here, right? So side AB. So here, going back to if you wanted to set up Pythagorean theorem, right, we could just count because that's going to also give us the slope. So here we've got a rise of 2, run of 2. So the slope is 2 over 2 positive, which gives you 1. Now we also can use that for our distance, right? Because that's 2 squared plus 2 squared, which gives us a distance, which is approximately radical 8. So now we're going to go to the next side. So we're going to go to BC here. So BC. So again, getting our rise, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So 5 over 5. Now notice, so we're going down. So this is a negative slope here. So this is negative 1. Then we can use those distances, right, to find our length. So 5 squared plus 5 squared and take the square root. So the distance is approximately radical 50. So notice, do we have negative reciprocal? Yes, because technically this is 1 over 1, which is the reciprocal of negative 1 over 1. So we do have the 90-degree angle. So that's one reason why this is a rectangle, because the slopes are the negative reciprocal, creating the 90-degree. And as we keep going, right, there's your 2 over 2. So opposite sides, and here 5 over 5. So opposite sides are also parallel and congruent to each other. So those are the reasons why this is a rectangle, using the distances and the slope. So then for this one, proving that we have a rhombus, so I'll start with WX. And so here, WX, we've got 1, 2, 3, and 1, 2, 3, 4. So 3 squared plus 4 squared, and take the square root, which gives us a distance of 5, right? Then, of course, we can use the slope here, because the slope is, oops, sorry about that. The slope is, here we go. So the slope is the rise of 3 over 4, and we're going up. So this is positive. So now let's go to the next side here. So XY. So again here, rise of 1, 2, 3, 1, 2, 3, 4. So notice how this is negative. So we have a negative slope, but again, rise is 3, run is 4. So do we have a 90-degree angle? No, because we do not have slopes that are the negative reciprocal. So that's one reason why this is a rhombus, because if this was 90 degree, then we would have a square. So we do not have 90-degree angle. Then let's keep going. So again, 3 squared plus 4 squared, and take the square root, which gives us a distance of 5. So notice we do have, though, congruent sides. So again, here, 1, 2, 3, 1, 2, 3, 4. Same thing. 1, 2, 3, 1, 2, 3, 4. So all sides have the congruent side length, but no 90-degree angle from the slope. So now question number 2. Here, we're just identifying the transformation. Now, use the coordinates to check, right? So like, let's say we're going to focus on point S. So S right now is at negative 5, 3, and S prime is at positive 5, negative 3. So notice, what did we do? Well, we just changed the signs, right? No switching, no nothing. So right now we're saying that this is a rotation of 180 degrees. So let's go to U. So U right now is at negative 2, negative 1. U prime is at positive 2, positive 1. So again, notice all we did was just change the signs. So there, this is a rotation of 180 degrees. So again, to that shortcut to check why this is not a reflection. So let's say if it was a reflection over the y is equal to negative x. So here you have to have straight lines. So a straight line, line. But then notice how here the S is all the way down here. It is not correlated here. So that's why this is not a reflection. So remember, for a reflection, all the points need to match up. So this is a rotation of 180. So same thing here. Let's check. ABC is mapping to STU. So A is at negative 2, 1, 2, 3, 4, 5. So negative 2, 5. And again, according to this, it's mapping to S. And S is at 1, 2, 3, 4, 5. So negative 5, negative 2. Now notice we did switch the coordinates, right? We switched them, but what did we also do? We changed the sign of the Y coordinate. Now notice it's a negative. So let's keep in mind that this is just a good old rotation with our big C, right? Counterclockwise. So here we go. Point B is at negative 1, 2, 3, 4. So negative 4, 2, and T, right? Because B to T. T is at negative 2, negative 4. Notice what happened. We switched the coordinates and we changed the sign of the Y. It went from positive 2 to negative 2. So this is a rotation of 90 degrees counterclockwise. So for those who are used to seeing that, right? But again, going with that big C, 90-degree rotation. Now, number 4, after reading the question, all we're focusing on is what are the coordinates of E? So E double prime. So right now, E is at 5, 2, right? So 5, 2. Now we've got two transformations. So the first is we're reflecting over y is equal to negative x. So remember, you switch the coordinates and change the sign of both. So this is negative 2, negative 5. Then we're going to rotate 270 clockwise. 270 clockwise is the same as a good old 90-degree counterclockwise, which is, again, we're switching but changing the sign of the y. So we're going to focus on the y here, and that's how you get positive 5, negative 2 here. So now here, what is the sequence? Well, I could tell, so let's focus on the points first. So A is at 4, 4, and it maps to R. So R, which is now at negative 4, negative 1. And then to check, B right now is at 3, 1, and B maps to S. So S is at negative 3, negative 4. So now I notice visually we've got a reflection here, right? Reflection over the y-axis. So let's check that, right? If we're reflecting over the y, then that means we just need to change the sign of the x. So this would be negative 4, 4, and this would be negative 3, 1. So now notice by reflecting, the x coordinates are where they need to be. But notice we go from 4 to negative 1, 1 to negative 4. So now we're going to translate, but do we need to do anything to the x coordinate? Do we need to go left and right? No. So I'll just put 0. And then here, we do, however, need to go down 5 or subtract 5 from the y. Notice y minus 5 is negative 4. And then for those who do coordinate form, this is just good old x, right? And then y minus 5. So now which statement is true? Because we do have congruent figures, right? Because of the transformations. So remember, corresponding parts match up. So angle A, if angle A is 28 degrees, then the measure of angle T. Well, does A match with T? No. So A is not our answer. So AB, side AB and side RS. Are these two congruent? AB, RS. Yes, they are corresponding. That's why the answer is B. So now going into 6 and 7, you need to make sure to draw the visual to see how you're going to set up and solve for X, but then make sure to check to see what you're answering in terms of the question. So P is inside, or sorry, that's a typo. Sorry about that. That was supposed to say NP. So NP is in the interior of angle MNO. So MNO. And NP is inside. Is it a bisector? No, it's just inside. So wow, we're done. MNP, so this angle here is 5x plus 7. ONP, so ONP, this angle here is 3x minus 2. Then MNO, MNO, this entire angle, right, is 10x minus 25. Now keep in mind, we're not just solving for x, right? We're going to solve for the measure of angle MNP, which is here. Notice here, are they equal to each other? No, because this was not an angle bisector, but they do add together to equal the whole, which is 10x minus 25. So 8x plus 5 here, right, from combining like terms, is equal to 10x, there we go, 10x minus 25. Now we're going to solve for x. So I'm going to gather the variable. So now you've got 5 is equal to 2x, right? From subtracting 8x from both sides. So we're just gathering our variables here, minus 25. Now we're just solving our two-step. Add the 25, so now we're at 30. It's equal to 2x. Divide by 2, and x is equal to 15. But like what we said, right, we're not done. We're solving for the measure of angle MNP, which is 5x plus 7. So 5 times x, or 5 times 15 plus 7, or 75 plus 7, which is 82 degrees. So now we're getting into RS bisects angle QRT. So QRT. And RS bisects it. So now we can show that these two angles are congruent to each other because we have an angle bisector. QRS. So this angle here is 3x plus 18. And SRT. SRT. So this piece here is 9x minus 12. That's all we're given, and we're looking for x. So how are we going to solve? Well, because this is an angle bisector, are they equal to each other? Yes. So 3x plus 18 is equal to 9x minus 12. Now we go through and solve for x, right? So just like before, we need to gather our variables, and 18 is now equal to 6x minus 12. Now you're just solving a two-step, adding the 12, 30 is now equal to 6x, and x is equal to 5. And we're done because we're just solving for x. So now here with question 8, H and G are parallel according to our statement, and we're solving for x and y. So notice here, well, yes, these two are alternate interior angles, but that doesn't really help us because this has x and this has y. But we are given this angle here, right, of 42 degrees. So if these are a linear pair, right, with our x, that means they're supplementary. They add up to 180. So 5x plus 18 plus 42 is equal to 180. We're combining like terms, right? 5x plus 60 is equal to 180. Now we're just solving a two-step. Subtract 60 from both sides, so 5x is equal to 120, and x is equal to 24. So I can go ahead and mark off B and C. So now looking at solving for y. Same thing here, right? We're going to use that 40 degrees. Now there are other ways, but I notice with y, they're not a linear pair. Notice how they're both on the same side of the transversal inside, same side interior, which means they are also supplementary. They add up to 180. So 3y plus 42 plus the 42 degrees is also equal to 180. So 3y plus 84 is equal to 180 here. Now we're solving a two-step. So 3y is equal to, well, that's subtracting, you get 96. And when you divide, you get 32. That's why the answer here was A. So now question number 9. So 9, we're given our triangle, all three interior angles. So we know that they all add up to 180 degrees. Now keep in mind though, we're looking for the measure of angle ACB, which is ACB. So in the end, we're looking for the measure of this angle here, right? However, we have to know what x is. We're going to add them all up, combining like terms. So 19x plus 9, because that's 8 plus 2, which is 10, minus 1, which is 9. Now that is equal to 180. Now we're solving our two steps. Subtract 9, you get 171. When you divide by 19, you get 9. But again, we're not done because we're looking for the measure of angle C. So 7 times 9 minus 1. That's how we get 62 degrees. So now number 10, we're focusing on an isosceles triangle, which means the base angles are the same, but we're looking for the value of x, which is an exterior. So keep in mind, in order to find the exterior, the x here, the opposite angles we have to add together to equal the exterior. So first, we got to figure out the base angles. Well, this is 180 minus 54, right? Which gives us 126 degrees. So does that mean that's each base angle? Well, no, because that's what these two. And because they're congruent in an isosceles triangle, divide by 2. So that's how we get that each of these base angles are 63 degrees. Now we can add up the two angles that are opposite from the exterior, which is 117, but that is equal to 3x plus 15. So remember, those two opposite, the remote, added together will equal the exterior. Now notice we're just solving a two-step equation. So subtract 15, you get 102 is equal to 3x. Divide by 3, and that's how you get a, because we're just solving for x, and 34. So now here in number 11, notice we are solving for an angle measure, VWU, VWU. So in the end, we're solving for this angle here. Keep that in mind. Now, we're given the exterior and we are given the two interior angles opposite. So again, these two angles add together to equal the exterior angle. So 28x minus 6 is equal to 25x plus 12. And so now here we can go through and just start solving. So I'm going to go ahead and gather my variables. So subtract 25x from both sides here. Now I've got 3x minus 6 is equal to 12. Now you're just solving a two-step. So adding 6, you get 3x is equal to 18. Divide by 3, you get x is equal to 6. But remember, we're solving this angle here. But in order to do that, I'm going to go ahead and plug in to the exterior because they're a linear pair and they add up to 180. So 25 times 6 plus 12. So when you calculate here, the exterior angle we just solved here is 162 degrees, which means if they add up to 180, subtract from 180, and that's how you get D, 18 degrees.